Hello everybody, welcome to another lesson of math. So today we are looking at the relationship between x and y and how it can be shown as a table or graph. So by the end of this session, hopefully we'll be able to plot a graph from a rule, and we'll be able to check if a point lies on a line. So last session we looked briefly at how to plot coordinates on a graph, and this is really important. So if you were a bit confused, I need you to go back, watch that video, and then come back here for today's lesson because we need to know that stuff for today. Basically what we are looking at is a linear relationship. So anything that is linear, the word linear actually means a straight line. So a graph that looks like this, like this, like this, or like this, okay? So there's 4 directions that our particular linear graph could look like, obviously on an axis. So a linear rule, okay, is going to define where our graph is going to sit on our set of axes or on our Cartesian plane. And it's often written in this form: y, which is our subject, equals something x plus or minus something, okay? So our y most of the time will be on the left-hand side, and our x most of the time will be on the right-hand side when we're describing our rule. Notice that we have an x and we have a y because when we draw a set of axes on a graph, okay, we always have our horizontal axes labeled as x and our vertical axes labeled as y. So in order for us to construct a graph, okay, to graph a linear relationship using a rule, there are 3 steps that we need to follow, and we're going to go through those steps in a moment. The first one is we need to construct a table of values, okay? The second one is we need to plot the points from that table. So this is why looking at the last session of plotting points is important. And then we draw a line connecting all of our points. So say I gave you a question, and that question is, I want you to graph, all right, the graph that would be for the rule y equals 2x take away 1. So I'm giving you a rule, y equals 2x take away 1. And I'm going to ask you to draw a graph. So the first thing I need to do is construct a table of values. Now what that means is I need to, for my table of values, I have x values and I have y values. We know numbers are positive and negative, okay? So I'm going to start off with, usually say the number -3. So I'm going to go -3, -2, -1, 0, 1, 2. I can go up and down as many times as I want, but that's enough for today. All right, we're going to figure out our y values. Now to figure out our y values, I need to substitute my x value into the rule, and this is why using algebra is really important. So when x is -3, okay, we need to figure out what y would be because that's our blank. So y would be 2 multiplied by, because remember between a number and a letter there's a multiplication sign, so 2 multiplied by x. Our first x value is -3, take away 1. Okay, take away 1. I can put that into my calculator or I can work it out. So 2 times -3 is -6. -6 take away 1 is -7. So I can see that when x is -3, my y value is going to be -7. So I can go in and I can fill that in on my table. The next one, when x is -2, okay, so we're going to do another equation again. So y equals, when x is -2, so we've got 2 times x, we're saying x is -2, so -2, take away 1. 2 times -2 is -4, -4 take away 1 is -5. Again, you can be working this out as we go, or you can just put this into your calculator. -5, so when x is -2, y is -5. So I'm going to put -5 in my table. And I'm going to keep going for the rest of them. So when x is -1, 2 times -1 is -2. -2 take away 1 is -3. So I'm going to fill that out. When x is 0, okay, so 2 times 0 is 0. 0 take away 1 is -1. So I'm going to fill that out. All right, now when x is 1, so 2 times 1 is 2. Take away 1 is going to be 1. And then our final one, when x is 2. So when x is 2, 2 times 2 is 4. 4 take away 1 is 3. And I can keep going, but I can already see a pattern, okay? So as my x values increase by 1 each time, my y values are increasing by 2 each time. We're going from -7, -5, -3, -1, 1, 3. There is a difference of 2 between each of these. So there is a pattern, all right? And when there's a consistent pattern, that's when we know that we're working with a linear relationship. Okay, so now that we've substituted each of our x coordinates from our table into the rule and figured out what our associated y coordinate is, we now have coordinates that we can plot on a graph. So remember, when we have a graph, we have an x and a y axis. So I'm going to go like this. And I'm going to say this is my x-axis, this is my y-axis, and I'm going to label them. So we're going to count. Remember, x scale goes this way, so we're going to go 1, 2, 3, 4, 5. I can go backwards, -1, -2, -3, -4, -5. Now the best way to do this is on grid paper, where we know that our spaces are going to be equal. All right, we can go up as well. 1, 2, 3, 4. My paper's getting a bit small, but that's okay. -1, -2, -3, -4, -5, -6, -7. All right, now what we have to do is plot our points. So if I look at my point here, I've got -3, -7. So remember, when I write my coordinates, I write my x1 first, so -3, and then my y1 second, so -7. So this coordinate on the graph, I would go x value -3, y value -7, which when I match them up will be over here, and I draw my dot. Okay, my next one is -2, -5. So I'm going to go -2 for my x value. Y value is -5, so we're going to go. There we are. There's my point. Okay, we go to the next one. -1, -3. So we're going to go -1 on the x-axis, -3 on the y-axis, and when we join them up, we end up right over here. Okay, 0, -1. So 0, remember, is at our origin. -1 on my y-axis is over here. And then 1, 1. So 1 on my x-axis, 1 on my y-axis would be there. And then 2, 3. So 2 on my x-axis and 3 on my y-axis would be joined up here. Now, what do you notice about these dots? They are forming a straight line. So what I would then do is I would use a ruler. Obviously right now I do not have a ruler. That is okay, but what I can do is, using a ruler, all right, if I have one, is now join up my dots, and they should be a straight line. Obviously, if I'm doing this on grid paper, they would line up pretty perfectly because each of my measurements would be the exact distance apart. So the first thing, just to recap what we've done, is I have been given a question to plot. I have then created a table. Usually you can go from some sort of negative number to some sort of positive number as your x's, and then you use that table and the rule to try to figure out what your y values are going to be. So to construct our table of values, we substitute each point into our graph rule to figure out what the corresponding y coordinate is going to be. We then, once we've constructed our table of values, can plot our points, and then we can draw a line to connect the points. Okay, so that is how you plot a graph when you've been given a rule. What we are now going to do is check to see if a point lies on a line. All right, so a kind of question that you can get for this is, we can be asked, we can say, decide if the point, and they're going to give you a coordinate, so 1, 3, and -2, -4. So they've given us 2 separate coordinates, lie on the graph, graph of y equals 3x. So they've given us a rule, they've given us two sets of coordinates, and they're asking us to see whether if we were to graph this, okay, like this, if we were to draw the graph, would these coordinates be on that line? So the way that we solve this kind of question is as such. So what we are going to do is look at our first coordinate as 1, 3. So I'm going to write that down, 1, 3, and I'm going to write down my rule, y equals 3x. So what I'm going to check is if I substitute the x coordinate, do I get this as my answer? So let's try. Y equals 3, remember between a number and a letter there's a times, 3 times x. So if x is 1, does my answer equal this value here? 3 times 1 is 3. Oh, that's the same as what I've got in my coordinate. So yes, this does lie on that line because the number that I got as my answer is what was given to me in the coordinate. Let's try this second one here. So -2, -4. Does -2, -4 lie on this graph? Okay, so if my graph rule is y equals 3x, what we're going to do is we're going to substitute this x value. So I'm going to say, what is y when x is -2? So 3 times -2. What is 3 times -2? 3 times -2 is -6. Is -6 and -4 the same? No, they are not. So, no. This coordinate does not lie on this graph. If this answer was -6 over here, then my answer would be yes. But because the number that I end up with is different to the y coordinate that was given, that therefore does not lie on the graph. If you have any questions about any of the work today, please leave a comment down below and I'm happy to answer them in the comments. Give this video a thumbs up and I'll see you next time. Bye.